Hello and welcome to today's Cracking the Cryptic, where we're going to take a look as usual on Saturdays at the Killer Sudoku, deadly rated from the Times. So without further ado, I'll put in the obvious answers and we'll go from there. And somewhat amusingly, in fact, there's nothing that obvious. So the 16 is 7-9 in this box here, which forces the 13 to be 5-8. And the first number I can immediately see we can fill in is this one in the final box in the bottom right hand corner, where the 20, the 10 and the 9 add up to 39, which means this box must be 6 because as we know the whole box must add up to 45. So let's fill that in. Now, one interesting thing I'd immediately note about this 15 box here with the 6 already in it is that these 3 cells have to sum to 9, which I think means they have to contain a 3, because it's either going to be 5, 1, 3 because it can't contain a 6, or it's going to be 4, 3, 2. And now I think the other thing we need to think about at this point is this 37 box. And one of the things you can immediately note, this is a 37 box, which is a pretty high number, and it's 37 in 6 digits, which means there have to be 3 digits. Well, there can only be 3 digits outside of a 37, if you like. Now, and those 3 digits have to sum to 8. And then 8 must always include a 1. So we can say that this 37 box is made up of all of the digits from 1 to 9, except a 1, and then either a 3 and a 4 or a 2 and a 5. We don't know which yet, but the fact that the 37 box doesn't contain a 1 is something I'd certainly be trying to make use of at this point, especially with the 8 here in the top right. So this we know does have to contain a 1, and therefore we know that the 1, well, we know the 1 in this box is either in one of these 4 cells. Fortunately, I can't quite see a way to make use of that yet. We can note though that if the 1 was in this position, and if this cell was a 1, we can see that a number of interesting things follow from the combination of this 36 huge set of cells and this 37 huge set of cells. I mean, if this is a 1 here, the 35 that would be left in the top right box here in 5 cells can only be made up of 5, 6, 7, 8 and 9, which would mean this would have to be 1, 3, 4 and this would have to be 2. And in fact, by simple arithmetic, whatever this number is, this number has to be 1 higher. So you can prove that to yourself. If this was a 2, the remaining cells would have to add to 34 plus the 8, 42, so this would have to be a 3, and that holds for any combination. But still, I don't think there's a way of making direct progress from that. There may be, but I'm not seeing it. So the other thing I'm noticing is that I can get a handle on these 3 cells within the 36. Because if we look at the first 2 rows of the grid, which we know must sum to 90, I've got boxes that are totally within those first 2 rows, except for these 3 cells, so I can isolate the value of these 3 cells. So let's just do that now. So we've got 8, 24, 29, 42, 52, 58, 67. So these 3 cells add to 23, which is a very useful number because 23 in 3 cells can only ever be 6, 8 and 9. So we should definitely note that, because a few things are going to be interesting as a result of that, I suspect. And we can see from this that the 8 and the 9 in the top left 3x3 box must be in the 3rd row, because we already have a 9, 2 9s here, and we have a 9 locked into the first 2 rows here. So there could never be a 9 in any of these cells. Otherwise there would be 3 9s in the first 2 rows, which is impossible, and it's exactly the same with the 8s. So we have an 8 and a 9 in some combination along these 3 cells. And that is extremely useful. I mean, one thing I'd immediately note from that is the 8 and the 9 can't both be in the 17 box, because otherwise this cell would have to be 0. So we know that this is an 8 or a 9. We also know that these top 3 boxes here sum to 25. So that these 3 cells have to sum to 20, and we know that 2 of them are 8 and 9, so the other one must be a 3. So let's note that. And that was a fairly crucial piece of logic, because now this has to be 2, 3. And you can also see that the 3 in this box has to be included within the 8. So this is 1, 3, 4. And now this 10, because the 3, 8 and the 9 are already appearing outside of the 10, this can only be a 4, 6. Which means, oops, sorry, I made a mistake there. Let's just delete that. I'm not quite used to the software still. Let's go back. Oh, something's going. So this has to be 1, 5. And this has to be 2, 7. So I've just filled in the rest of row 3 according to the only things it can be. We can now, in fact, lock the 6 in here, because it's the only place the 6 can go. And we said that this cell has to be 1 less than this cell. So this could be a 1, it could be a 4, or it could be a 6. Well, it can't be a 6 because of the 6 already appearing in column 7. So we can remove the 7 as a possibility here. And another simple piece of elimination. So we've got 3, 8, 9 in the 17 here, but we know it includes a 3. So these two cells either sum to 11 or 12, which means this is either a 5 or a 6. And you can see that it can't be a 5 because we already have a 5 in column 2. So let's make that a 6, which means that this actually has to be the 9. And actually, that leads to another interesting thing to note. If we look at column 3, we have already got 10 here. We've got a 15 box here, entirely within column 3. So these 2 boxes add to 25. And then we've got a 9. So that's 34. So we know these 2 cells sum to 11. There are very few ways of making 11 that would still be valid here. We can't have a 2-9 combination. We could have a 3-8, but we can't have a 4-7, and we can't have a 5-6. So in fact, these 2 cells here are 3-8 in some combination. We should note that. And we can immediately see, actually, now if we look at columns 1 and 2, these 2 cells we can isolate the value of, because all of the boxes in columns 1 and 2, apart from these 2 cells basically, are entirely included within columns 1 and 2. So we've got 30, 50, let's include this, 70, 87, 93, 102. So we know that these 2 cells have to add up to 12 in order for the first two columns to add to 90, which means that the only combination that's valid there is 4, 9. That might have been useful if we'd have got a 5 and an 8 as an option. We didn't get it, but we should still keep track of it. So let's remember that. The other interesting thing about this summing to 12 is that these 3 cells have to sum to 8. And because we've already got a 3 elsewhere in this 3 box, in fact, we now know this has to be 1, 2, 5. And that's really helpful because, look, if these I'll actually note it in just to make it absolutely clear what I'm saying here. These 3 cells have to add to 1 to 8. They have to be 1, 2, 5. And in fact, we've already got a 1 and a 5 in column 2. So this cell, I think, has to be a 2. And a quick scan of column 1 confirms that I think the only valid combination for this 10 box now is 4, 6, because everything else is not possible, because we already have a 1 in here, so 1, 9 isn't possible, 2, 8 isn't possible, and 3, 7 isn't possible. Let's look at what's still possible in column 1. We need to place a 3, an 8 and a 9 still in column 1. Well, you can see immediately this can't be a 3 or an 8 because we already have a 3 and an 8 in the box, so this has to be a 9. That's useful, unless this is 3, 8 in some combination. We're getting a lot of help here by being able to eliminate 2-cell combinations. So these 2 cells have to sum to 11. Well, it can't be 2, 9, it can't be 3, 8, could be 4, 7, and can't be 5, 6. So in fact, this is 4, 7. These two, and you can see what's going to happen here again. This is 4, 7 in some combination. Well, this one has to be the 7 then, because the 4 is already taken. Means this has to be a 7. I've just filled in the remaining options here in the bottom left box. So far, actually, a very nice puzzle today. A lot more interesting than the 1 or 2 we've looked at, and it's still holding up. So even though we've got quite a few numbers in the grid, we've eliminated quite a few possibilities for various boxes. It's not what I would call collapsed yet. It still feels like there's a piece of logic we need to find to really break the puzzle open. I suppose I've just spotted that the 6 has to be here. Let's note that, see if that gives us anything. There's a couple of things I'd note at this point. The first is that because we've locked the 2, 5 into the 37 box here, we now know with certainty what the 6 digits are within this 37 box. We just don't know how they're arranged. We know that because we knew we had to eliminate one of the 8 combinations in 3 cells from this 37 box. We knew either these 6 cells would not contain 1, 3, 4 or 1, 2, 5. So we know now that this cell is either a 2 or a 5. So we know that the cells not included within the 37 are 1, 3, 4. So this is 2, 5, 6, 7, 8, 9 in some combination, but I can't quite see how to make use of that. The other point I would note is, let's take a look at this 24 box in 4. And the reason for looking at this is simply that we've got a very limited set of possibilities now, given that we've narrowed these 2 cells down and we already have the 9. So let's just hypothesize that this cell's a 3. If this cell's a 3, these 2 cells have to add to 12, which is only possible if this is a 4, because you can't have 2 6s. Now if this is a 4, this is an 8, but it can't be an 8 because the 13 up here eliminates that possibility. So in fact this cannot be a 3, this must be an 8, and that looks like it might be quite useful. It certainly allows us to put that in there, and you'll remember we needed these 2 cells to add to 12, so this must be a 9, which is also quite useful. We know these 2 cells have to add to 7, so the possibilities here are 1, 3, 6, I think, but it can't be a 6 because there's a 6 here already, so it's either a 1 or a 3. And this cell cannot be a 1, because if it was a 1, this would be a 6, which is impossible. And the next place it feels like we need to take a look at is now a 1 is locked into one of these 2 positions, which means that the remaining 3 cells need to sum to 18. So let's imagine this is a 1, 4. It's either going to be a 1, 4 or a 1, 6. Let's just try 1, 4. 1, 4 would mean that these 2 cells have to add up to 14. Which would mean they have to be 5, 9 because we already have a 6, 8 here. Well, they can't be a 5, 9 because we already have a 9. So again, that's pretty helpful. This has to be 1, 6, which means this has to be a 4. Let's make that a 4, which means this is a 3. And remove the 4 possibility here. And the only way that these two cells can add up to 12 now, which I think they have to, is if they're 5, 7. And you can see that's, oops, not 5, 8, 5, 7. And because we already have a 7 in the 16 here, this has to be the 7. This has to be the 5. So we're really, it's a grind this, it's quite interesting. I'm enjoying this puzzle. It's holding onto its secrets for longer than one might have expected. I think we're almost there now. You can see that that's a pretty big breakthrough, the one we've just made. Something interesting to note here, I'm not sure it's that helpful, it's a little bit helpful. Let's take a look at column 4. So in column 4 we've already got 5 numbers, and if we extend down here you can see only these two cells are poking out from column 4. So let's just do a bit of arithmetic and see where this takes us. So we've got 13, 22, 29 here, which means these 4 cells have to add up to 16. But these two boxes sum to 26, so we know these two cells add up to 10. And we already have a 2 and a 3 in this column. So the only way that these two cells can add up to 10 is if they're 1, 9 or 4, 6 in some combination. Now, this cell here can't be a 9. So the only options for this cell are 1, 4 and 6. But 4 is impossible, because if this was a 4, this would be a 3, which is ruled out by column 4. So this can't be a 4. So in fact all of that logic allows us to conclude this is a 1, 6 combination, and that's quite nice. Now, and because we know these have to sum to 10, this is 9, 4 in some combination. We don't know which yet. But I quite like that. And one of the reasons is that it limits the possibilities for this 9 slightly. I'm going to show you another piece of logic here, which is a little bit naughty, but it's a technique that's worth knowing. So we can see that this 9 cell, it can only either be 2, 7 or 4, 5, because 1, 8 is ruled out by the 7 and 3, 6 is ruled out by the 7. So this is either 2, 7 or 4, 5. Now let's just imagine it was 2, 7 for a moment. I'm going to put this in to show you why. And let's scan upwards, and we can see a 2, 7 here in the 36. So now one of the things we know about these puzzles is that they have a unique solution. Okay. Now I hope it's obvious to everybody that this puzzle, if this was 2, 7, if this 9 was 2, 7, this puzzle does not have a unique solution anymore, because you can either this is a 2 and this is a 2 and this is a 7 or this is a 7, or the other way around, and both are entirely valid. There is no way of of saying which one of those combinations is wrong. So the puzzle would have 2 solutions if this configuration was allowed. So it can't be. Now that's a bit naughty. I probably shouldn't use uniqueness as a condition to solve this, but I would absolutely use it in competition in order to get to a quicker solution. So in fact we know this is 4, 5, and because there's a 4 here, we know that this is the 4, which means this is a 2. I don't feel too guilty about that. I hope that, and I think it's worth showing it because it's a technique we haven't looked at before on cracking the cryptic when it comes to these logic problems. And uniqueness is quite powerful in some puzzles at some times. Now you'll remember when we were identifying the possibilities for the 3 cells here, we knew it was either going to be 1, 3, 5 or 2, 3, 4. Well, now the 4 option is totally ruled out because there's no place to put a 4. So the fact that this can't be 2, 3, 4 and it has to be 1, 3, 5 means with the only place a 5 can go is here. And that has to be a 1 and this has to be a 3. And I've just filled in the options here just to make it clearer. And the next place I think it looks like we need to look is column 6. So column 6 we have a 17 box and a 16 box, 33. So these 3 cells must add up to 12. We already have a 5 here. So these 2 cells have to add to 7. So you can see the only option here is this has to be 1, 6 as well. And it can't be 1 because we already have a 1. So this is in fact a 6. That's a 1 and that's a 6. And that looks like it's going to be pretty helpful as well. Now this has to be a 4. Now this cell here, all the way down at the bottom, has to be a 9. We know these 2 cells have to add to 10, so this is a 1. That 6 would have also told us that. There we go. And I think the puzzle's now collapsed. We have too much information for it to resist us any longer. So I'll do the rest of it to music. And I hope this has been interesting. I think this has been a much better puzzle today, and there are some definite learning points from it. And as I say, techniques we haven't discussed before. So thanks very much for watching, and we'll see you again next time.